Assalamualaikum and hi. My name is Wishita Fariha binti Muhammad Fikri. My matching number is 2010925666. And today our group will present about power generation of wind turbine. I will start with the introduction. As you know, wind power generation is an energy resource through a wind turbine that transforms the kinetic energy into electrical energy. Wind is the centerpiece of the energy economy. It is abundant, low-cost, and widely distributed. It scales up easily and can be developed quickly. Wind power is the use of wind turbine to generate electricity. Wind turbine can be found in onshore and offshore. Offshore wind power is the generation of electricity through the wind farm in bodies of water, usually at the sea. These include areas such as lake. The wind speed is higher in offshore, so offshore farms generate more electricity, while in the onshore wind energy is the power that generated by wind turbine located on land, driven by the natural movement of the air. A lot of countries use wind power because it only required a minimal maintenance and for sure we have wind almost everywhere. So the windier the area, the more energy it can be produced. In Asia, India has the second highest wind capacity and one of the biggest onshore wind farms in the world. It is located in Kanyakumari district, Tamil Nadu. They have a turbine farm called the Mupandal Wind Farm. The capacity is 1,500 megawatts, which makes it the third largest operational onshore wind farm in the world. Tamil Nadu has some of the highest wind energy potential in the country. The season starts from May to October, another one from November to March. The winds are strong in the first season than the second. So during this season, the wind speed can exceed from 43 to 46 km per hour. Furthermore, there are few factors influencing wind power in Tamil Nadu. The first one is based on the location. Tamil Nadu is one of the best windy countries. It is situated at the southernmost tip of India, where it is surrounded by seas. Other than that, there is a wind monsoon, southwest monsoon, which only happened in May, June, and July, and northeast monsoon happened in August, September, October, and November. So during this monsoon, the Tamil Nadu will become very windy.
Now we look to the theory. The general theory of converting the kinetic energy of wind into mechanical energy by rotating blades of the wind turbine, and later the mechanical energy is converted into the electrical power by utilizing an electrical energy. The rotor consists of the wind turbine's hub and blades. These are the turbine's most crucial parts uh, from the perspective of performance and overall cost. Next, the other rotating components of wind turbines are located below the rotor that are called the drivetrain. Uh, Most wind turbines use either induction or synchronous generator to generate electricity. Once the generator is connected directly to the utility grid, this design needs rotating speed that is practically constant. The generator can run the turbine at a variable speed if power electronic is utilized. The nacelle and yaw system includes the wind turbine housing, the machine bed plate, or we call it mainframe, and the yaw orientation system. The nacelle cover protect the contents from the weather. Control are also important parts to boost machine and power production. A wind turbine system includes sensor, controllers, power amplifiers, actuator, and intelligence. As in slide show, the kinetic energy gained from the rotating blade which convert wind into mechanical energy. This mechanical power is transferred to a shaft that the gear mechanism. An AC generator uses the rotation for converting the mechanical energy to the electrical energy. An AC to DC converter is used to convert AC to DC current, which is then is used to charge a battery. The output, the output frequency and amplitude are configurable. An inverter uses the battery output to convert the DC voltage into any desired AC output voltage. The frequency also can be adjusted to the desired value.
Hi and Assalamualaikum. My name is Norehana. I will continue with my part, which is content. Based on content, I need to answer 4 questions that are given. The first question is how many of the population got access to the electricity produced? As we know, wind energy are found all over the world, and I choose India because India has a large amount of wind energy, and the capacity in India significantly increased in recent years. And the top state in India of wind turbine is Tamil Nadu. The Tamil Nadu at Mupata Wind Farm, and this project are located in Kanyakumari district. The population can access the power that can produce by installing the capacity until 1050 megawatt, which is the third largest operation onshore wind in the world, and the share of wind power in electricity generation was around 2.8% in 2018. In fact, the other wind often produce poor capacity. The poor capacity is the lower capacity is from 500 kilowatt, and the lower higher is 25 until 30 meters. Percentage of the type of power generation in the energy mix. The power generation is one of the most significant characteristics of renewable energy. So, aside from capacity, there was environment effect. Next, according to the seaway assessment, the production of wind energy can reduce the effective like sulfur, nitrogen, and carbon. The percentage has become to be more than 60% of the country wind power till today. However, today the Indian wind manufacturing industry has gained the distinction of being the third largest in the world. India is home to some of the biggest turbine manufacturers in the world. Question 3 is about, are there any government's commitment toward promoting a sustainable and cleaner production of the type of power generation? So, the Indian government policy framework for wind energy generation is very investor friendly, and regulatory structure and the tariff structure lay a solid foundation for the sector. So yes, the Ministry of New and Renewable Energy recently decided to implement generation and best incentive the program where investors will get paid for each unit of electricity produced over a 10-year period. Besides that, wind energy also can assist with the government why is true that a significant amount of capacity is needed to produce wind energy. That is untrue. The last question is, compare 3 of the power generation already existing in Southeast Asia. Other regions can be considered if the type of power generation is still uncommon in Southeast Asia energy. The 3 of countries that I choose from Southeast Asia are Malaysia, Indonesia, and Philippines. The size, developed, located, and the date operation was different. In Malaysia, the size is 150 kilowatt of wind turbine installed by the Tenaga Nasional Berhad. They located in Kuala Terengganu, Terubun Layang, and the date operation is 2005. In Malaysia, wind power is a significant renewable energy source and strategy located in an area with laser wind speed. Malaysia faced multi-challenges in the development of wind energy, where both land and sea wind can influence with patterns. The direction of the wind varies by season and location. As a result, characteristics of wind speed have predominated in Malaysia. Second, in Indonesia, the size is 30 wind turbine with a total installed capacity of 70 MW, developed PT UPC, located Sidrap Bayu Energy, Sulawesi. Their operation in 1 March 2018. They reduce air pollution by switching to clean, renewable energy instead of coal, oil, and other fossil fuel. The project produced 250,000 MW of renewable energy per year. The South Sulawesi National Grid enough to power over 17,000 local homes. Lastly, in Philippines, the size is 1.65 MW wind turbine that arranged in a single row stretching along a 9 km. That developed a power North Wind Group and located Bungoy Iliko Norte in that operation 20 June 2005. Maintenance and operation this project while Vitas Wind System supplied the wind turbine generator units for the site, similar to those already found in Denmark. The project was have been developed in 3 phases, with phase 1 of the project on June 2005. That's all from me. Thank you.
Assalamualaikum and hi, my name is Erisa Ariana and my matrix number is 2010909557, and I will continue with my part, which is the discussion about the advantage, disadvantage and the environmental issues for the wind power generation. As in my research, there were 6 advantages for the wind power generation, which is the number 1 is it is clean, sustainable and abundant. Number 2, it is cost effective. Number 3, it has higher level of price stability. Number 4, it is efficient use of land. Number 5, it is revitalize rural economies and support agriculture. And the last one, it creates job opportunities. I will explain further for each advantages. For number 1, the spinning of its blade is not fueled by any fossil sources. That means that during the energy production cycle, the power it produced from this resource doesn't contribute to the challenge of climate change. Besides that, there is no risk of the mercury contamination polluting the lakes or streams. Since there are no greenhouse gas emissions from the electricity it produces, it is considered a clean energy source. Although wind turbines can be quite expensive to construct, their cheap operating and maintenance expenses easily offset that initial investment. The levelized cost of energy (LCOE) of wind is cheaper than coal and gas, as well as many other renewable energy sources. Even though the wind may not always be a reliable resource, there are some places where it blows consistently all year. A higher level of price stability is made possible by installing turbines in these areas to create a utility resource than is possible with fossil fuels. Despite their size, wind turbines only occupy a small portion of the land. Through leases or contracts, farmers get paid for the construction built on their property. While ground level interruptions are kept to minimum, these payments serve to boost their agricultural revenues. Wind farms offer a consistent source of revenue that can assist farmers in navigating the unpredictable nature of farming. Wind energy has helped farmers endure through the uncertainties as droughts, floods, tariff, and fluctuating price have become more frequent in recent years. Additionally, wind energy has boosted the tax base in rural areas, reviving the local economy and enabling the construction of new public facilities like schools. Jobs created by wind energy projects team have both short and long-term benefits for the local, state and federal economies. From structural engineers to land surveyors, a variety of jobs are available. Jobs in industry include those for assemblers, turbine inspectors, meteorologists, and lawyers. Continue with the disadvantage. There were also 6 disadvantages for wind power generation. Number 1, it is a variable source energy. Number 2, it is not aesthetically pleasing. Number 3, it creates noise pollution. Number 4, it encourages ground erosion. Number 5, it impacts wildlife. And the last one, it has low efficiency rate of wind energy. So since it is a variable energy source, it cannot be produced when needed. Since wind farms depend on the wind blowing, they cannot by itself provide a sustainable and dependable electricity grid. Nevertheless, the energy storage technology is developing and becoming more affordable, which is assisting in stabilizing the supply and demand for energy. Electrical grids currently need extra sources of power to supplement the periods when energy demand is high and the wind isn't blowing. It is not aesthetically pleasing because different people react differently when they see wind turbines in nature. Some individuals consider the presence of wind turbine to be a blight on a rural or natural landscape. The flickering shadow that wind turbines cast as their blades spin is one of the main issues. Both people, those who have sensitivities to light, and animals may find this flickering shadow unsettling, and some communities may suffer from this visual pollution. Wind turbines are quite noisy. The older turbines still emit a bothersome amount of annoying noise. Residents who live close to wind farms may find the residual noise that the rotors make as they start spinning upsetting. Due to their enormous size and weight, wind turbines require a lot of space and heavy equipment to be built, which means that during the entire construction process, the surrounding environment is disrupted. When a high altitude or offshore installation is under conducted, these projects may even encourage land erosion to persist in some areas. Those farms that want to plant crops near their wind turbines may find this to be extremely destructive. A blade strike from this technology could harm or kill bats and birds that have migratory routes or habitats close by. Installing wind turbines may have a negative impact on the land, which may have an impact on the species that once inhabited there. Additionally, offshore wind farms may damage fish habitat and have a harmful effect on marine habitats. Efficiency rates for wind energy projects are frequently under 40%. Some onshore areas are under 30%. The limitation of the wind speed at which the turbines may operate is directly to blame for this disadvantage. Many of them require a breeze of at least 5 mph in order to function. The turbine stops spinning to prevent damage if the wind is blowing too hard. Since the blades aren't spinning, the operational range frequently ends at 35 to 55 mph, wasting a significant amount of energy. So now, I will explain specifically about the environmental issues: wildlife safety, biosystem disruption, noise, visual pollution, electromagnetic interference, local climate change, and biosystem disturbance are the main environmental concerns associated with the use of wind turbines. Birds can be killed when they run into a wind turbine's revolving rotors, or they can sustain fatal injuries when they run into a turbine towers, nacelles, or other building in a wind farm. Alright, so according to Laws and Others, accidents with monopole wind turbines in the United States result in the death of 234,000 birds on average every year. According to Seider and others, bird death rates for wind turbines with rotor diameter ranging from 33 meter to 72 meter in various US areas average is 2.3 birds per turbine per year. Bird species meteorological circumstances Wind turbine design and layout are only a few of the elements that affect birds that caused by wind turbines. The habitat of local birds could be destroyed as a result of the construction of wind turbines and related infrastructure. Nearly a quarter of all bat species in North America are currently affected by wind turbine-related bat death. According to research, migrating bats as well as bats from local populations were killed by wind turbines. Bats may be drawn to the ultrasonic emissions and lights of wind turbines, according to Arnett and others. Another theory is that the bats attempt to exploit the wind turbines as potential roosting locations by treating them like trees. The tremendous heat radiation from wind turbine nucleus may also attract a lot of insects, which may lead to an encampment of hunting bats near the turbines. Fish may suffer detrimental impacts as a result of the electromagnetic fields and noise that surround wind turbines. Seals and other marine creatures may react to wind farms, particularly while pile driving is being done during the construction phase. Oil or waste can enter and contaminate the seawater nearby during wind turbine maintenance procedures like part replacement or lubrication. The local biosystem may be impacted by certain wind farm development activities such as road construction and foundation excavation. The removal of surface plants would expose the soil to heavy winds and rain, which would cause soil erosion. Oil and wastewater from the construction site could seep into the soil and cause several environmental issues. Rich wind resource areas such as grasslands, moorlands, and semi-desert frequently feature fragile ecosystem and little biological variety. Heavy machinery use during construction may damage the local ecobalance, and it could take a while for the environment to recover. Aerodynamic noise and mechanical noise are both components of wind turbine noise. The sound of the turbine blades moving through the air is caused by aerodynamics. This noise changes with turbine size, wind speed, blade rotation speed, and is perpendicular to the rotation surface of the blades. Obviously, a large turbine and high wind make more noise. Noises can originate from different directions at different times, since new turbines can spin to face the upward direction of the wind. With a change in wind direction, some turbine blade pitches can also automatically vary, producing noise at various decibel levels. Broadband noise, which includes a variety of frequencies, is what is referred to as aerodynamic noise. The turbine's internal gears, the generator, and various auxiliary components all produce mechanical noise. These sounds can be heard and are bothersome, especially for wind turbines with insufficient insulation. The visual impact of a wind turbine can be influenced by the number of blades and the direction in which they rotate. According to Sun and others, a wind turbine with 3 blades is preferable than one with 2 blades for persons who are sensitive to visual impacts. The turbines with 3 blades have a propensity to provide a stronger sense of balance, which may be the cause. Wind turbines with blades moving counterclockwise cause viewers to experience more visual disturbance.
Assalamualaikum and hi, moving on to my part, which is mathematical model. Wind power is a renewable energy power that harnesses the full potential of the wind. Through the usage of wind turbine, kinetic energy is converted into mechanical power, which is subsequently converted it into electricity, which is used as the source of energy. One of the main renewable energy sources used to generate electricity in India is wind power. The nation presently ranks 4th in the world for wind power generation with 37.5 gigawatt of installed capacity. As shown is wind energy formula, which is P equals to 1 over 2 times with rho times A and times V cube, where rho is the density in the unit kg per meter cube, then A is the area in the unit of m square, and V is the velocity or the wind speed in the unit of meter per second. Next, we have the derivation of wind energy formula. The kinetic energy of an item with mass m and velocity v under constant acceleration is equals to the work done W in displacing that object from its original position. Under a force F, rest to a distance where E is equals to W and equals to Fs. According to Newton's law, we have F is equals to ma. Hence, E is equals to mas. Using the third equation of motion, which is v squared is equals to u squared plus 2as, we get A is equals to in the bracket of v squared minus u squared divided by 2s. Since the initial velocity of the object is 0, we get A is equals to v squared divided by 2s. By substituting it in equation 1, we get the kinetic energy of a mass in motion is E is equals to 1 over 2 mv cubed. The power in the wind is given by the rate of change of energy, where P is equals to dE per dt equals to 1 over 2 v cubed dm per dt. As mass flow rate is given by dm per dt equals to rho a dx per dt, and the rate of change of distance is given by dx per dt equals to v. We get dm per dt is equals to rho av. Hence, from the equation 3, the power can be defined as 1 over 2 rho a v cubed. That's all for me. Thank you.
As a conclusion, wind power costs are much more competitive with other generating technologies because there is no fuel to purchase and minimal operating expenses. Wind power is attractive, providing a cheap and flexible electricity supply to dispersed communities. The development of wind farm has also paved way a good road, school, and water tanks. Hosting wind farm also can provide farmers with a steady income. Thus, at this moment, wind power is the only renewable energy that has the advantage of maturity, cost competitiveness, and modularity. That's all from our group. Thank you.